So welcome everybody to this webinar about unit and software integration tests in safety critical projects. Short introduction to myself. I have a strong background in aerospace, and from my perspective or experience, this is the sector where there is overall the most of the experience in these areas to make these things effective and have its high quality. As Paulina said already, I started electrical engineering in Augsburg some decades ago, almost. I've been self-employed as a freelancer from 2005 to 2017, and since 2018, I'm the owner of HEICON. 20 years of experience, and all the as you see the sectors: aerospace, automotive, railway, industrial. The HEICON motto or topic is there is only one good software development process independent of the sector. And you can see this even in the functional safety standards now with respect to software. And the topic we are talking today, especially unit integration testing, it's getting more and more similar, in the different sectors. HEICON is focusing on three topics, mainly overall on consulting, hands-on consulting, and there then requirement engineering, test engineering, and functional safety, planning, documentation, strategies, audit, and assessment consulting. In the webinar now, I have broken down the topic into these sectors here, giving a short introduction, topic white box testing, unit testing, integration testing. So do a bit separation and definitions so that we are getting a similar understanding, or that you know what I'm talking about overall here in this webinar. So then, what is about expected functional test results? How are these determined? How should they be determined? How are they determined and how should they be determined? Where are their topics in the industry? Then, which test methods are used to create normal range test cases? And then where it's getting interesting for a test engineer, normal range test cases should be done by everybody, every engineer, every developer. But if you call yourself a test engineer, then you should be more there. Which test methods are used to create robustness robustness test cases? So it's not the job of a test engineer to prove that the system is working. This should be already done by the software development people, engineers. It's to prove that it's not working, if you want. These are the robustness test cases. So where are the boundaries of the system, boundaries of the software? Error guessing is in the 26262, the topic there. So then the next topic is then what role plays the structural source code coverage? Is this the solution of everything in unit integration testing, or is it only a part of it? Which part and what roles should it play? Let us talk a little bit about that. Then how do you successfully and efficiently perform test reviews? I've seen so many reviews ineffectively, and waste of time and money is unbelievable in the last 20 years, and a review properly performed is really helpful. And all our safety standards, also 26262, is actually relying on, in software areas, the 4I principle. Everything we are doing should be reconsidered by a second person, because that's the only way how we can detect failures introduced by humans, by ourselves. And software development failures are introduced by humans. There is no physics behind it. Creating software is writing source code, writing text in a text editor, if you take it very extreme. So reviews, what is about reviews? So the last one, a summary, the take-home message for you. Before I then hand over to Roland, which will show you CTC and implementation of measuring code coverage. Very good implementation in the end of this webinar. So after 45 minutes, which is now my schedule. So let us start with the introduction. Let us start with the ISTQP glossar. You may know, some of you may have actually an ISTQP certificate. And unit testing, okay, I have here the definition of white box testing, because a lot of people are using this as a synonym, yeah. And when we say white box testing, what is the ISTQP defining it? He's saying it's the test based on testing based on an analysis of the internal structure of a component or a system. There are other synonyms according to the ISTQP, which are there: clear box testing, code-based testing, glass box testing, logical coverage testing, logical driven testing, structural testing, structure-based testing. The last two are the ones which I may use here in this webinar as well to some extent. Code-based testing is telling a lot. I want to, from the naming, yeah, I want to show you in this webinar that this is overall not the best idea to take the source code and test the source code in itself, yeah. I will help you to make it in a better way. So this is the ISTQP definition of a white box test, the internal structure of a system. So this is actually more general. It's not only source code and a unit, yeah. But for us in our area now, for the unit testing, when our component or system is the software unit, yeah, then the internal structure is the source code. The ISTQP try to define it very, very generic so that you can use this term more often. In practice, from my perspective, as said, this is the source code in 95% the cases. Yeah, I have not seen many other cases where we talk about white box testing and then not the source code. Yeah, very, very rarely. So if we go into the V model, which all of you may know, the development phases there, you see on the left side, there's a HEICON specialty here of the V model, distinguishing clearly between requirements, here system requirements, software requirements, and maybe even a level down, yeah. But for our webinar here, these two levels, and in parallel having an architecture, which is this requirements are textual representation of our system. The architecture is a graphical representation. So enterprise architect, MATLAB Simulink, model-based development, all models which are existing software, modeling software, are actually a representation of the architecture of the software. So this is the left side, and we are talking here now in this webinar about the right side, the testing, and we start on the lowest level, the unit testing, and we will have a discussion about the software integration testing. And you see here this error. We have the functionality, of course. I hope everybody can agree. If we test a unit only, we see the functionality of this unit, but this functionality may be reading a parameter or setting a value or storing something, yeah. In opposite to a functionality of a system, detecting some temperature values and having a special situation and then deciding to switch on a light and to send a CAN bus message. So this is let's say a greater, bigger functionality, a real functionality, if you may. So in that sense, it's here meant testing of functionality. Testing an integrated system is more on these higher levels, of course. But what we are talking about is here now on the lower levels, software integration and software unit testing. Typically in the industry, we have, on these higher levels, we have requirements which we can test, yeah. Customer requirements, system requirements. So the system test and the hardware software integration test, is typically testing software requirements, system requirements. In automotive industry and most of the other industries, except the aerospace actually, these lower level tests are testing if we are happy the software design. So low level architecture, low level design. In graphical representation, we have very often not really textual requirements, at least not for unit testing. Yeah, as you see, software integration testing here could sometimes test the requirements, and this is part of this webinar here to give you an idea how we can improve that. Yeah, what is going on here? Because if we have nothing on the left side to test, yeah, and we test only on the right side, the unit tests especially, yeah, then we test the source code against itself. So then we can conclude the source code is doing what the source code is doing. But that's not what we want to have. We want to find failures in our testing. And this V model already shows you there is a topic in unit testing. Overall, as I showed before, these lower levels are called white box testing and the higher levels are called black box testing. As we close the box here on system level, we have only the external interfaces and we have requirements and we're testing this against the requirements. So this is the black box part of it. If we go back to this white box unit testing, it's typically performed by a software developer before a software module is integrated. This should be done. Yeah? Whether it's done always, it's another question, but that's the idea of white box testing, of unit testing. The measurement of the structural source code coverage is nowadays done by tools, yeah, like CTC from VerifySoft. It's not done by hand anymore, which definitely makes no sense anymore, but was in previous times, 20 years ago, did even do this by hand, structural source code measurement. The white box testing, the code coverage is required by all the functional safety standards I have seen. Actually, there is none. Here are some examples, but it's not all of them. And most of these, or these four, all of them, but most of the other ones also require 100% structural coverage. In the railway, you can debate because there is not really mentioned 100%, but it is actually expected. Yeah, we are nowadays not arguing anymore that we have less than 100%. An assessor wants to see an argumentation at least about the complete source code. The aerospace is the special industry. It is different to all the others as far as I have seen. They have 40+ years of experience. I mentioned here, measuring it by hand. Yeah, I have my first aerospace project have been measuring the structural coverage by hand. So that's this 40 years of experience here. They have a hell a lot of experience, and that's where other industries can really benefit. It's beneficial for others. Yeah, and as HEICON and me are out of the aerospace, I try to transform or to help you, giving you some insights on that in this webinar here. In IT software projects, so not embedded, the structural coverage from my perspective makes no sense. It's not really used. These guys developing applications for the PC and so on and so forth, they are not measuring source code coverage mainly. At least not these 100% topics. Yeah. So here are the aerospace experience. 100% structural coverage alone means nothing. Yeah, and this was never the idea of the structural coverage measurement. To measure 100% and find failures is not even the idea of measuring the structural coverage. But 95% of the people nowadays think of that like, yeah, therefore we are finding problems. No, it's not. So another point is, and we're coming to this topic later actually, performing white box tests in a team which does not have developed source code is very expensive actually. Yeah, as yes, we need sometimes to do this. There are very critical projects as a SIL4, DAL-A, ISIL-D. Yes, it makes sense. Yes, we need to do it, but we need to understand that this can be expensive. Yeah, because document everything what you need to test it at 100%, not looking into the source code. Things like that makes it expensive. The software integration level is most beneficial for white box testing, not the unit and module level. And I will also give you an insight in this in the webinar. And the measuring the structural coverage can support the argumentation that the used compiler does not introduce failures into the operational object source code. That is also important here, is very, very important. Yeah. Nowadays, especially automotive industry, we have many, there are many compiler vendors. They are providing you now some safety packages and God knows what. Yeah. But the best is still to test your source code, compile it exactly like you do it in the original version, and measure 100% coverage and do 100% requirements coverage. That's still the best way to prove that your compiler has no failure for your software. And that's enough. You don't need to find any failure in the compiler. It's just compiling your software. That's good enough. And that's what you should think about when you're doing this white box testing, that your compiler is there also involved. Okay, you see, we have a strong program in front of us. So it's this whole webinar gives you an overview, definitely. You have to, not much more. Asking questions, come back to me or to VerifySoft after the webinar. If you have further questions, we will help you. Here, the idea is to highlight things and to show you how powerful this topic is. So how are the first thing, what is about the expected results? I said already 100% coverage is not the topic. Yeah. So what is about these expected functional test results? Yeah. Start here. Creating a test with only the goal of achieving 100% structural coverage is meaningless, because this means you test the code against itself. And this is against almost any test book I know, at least. As in the test books, we still have this very strong separation of unit testing equal source code testing. Yeah, and we are testing all the structure of the source code. And somehow we know what is correct and what is wrong. But the experience in the industry and aerospace especially, this is meaningless. Yeah. Even the developer itself, he cannot question his cost. He has done the source code, yeah. So the source code will be correct for him. So if this is not the way, what is the way? The way should be specifying, thinking about what is the functional focus on your unit even. What inputs is going this unit? What are you expecting functional from the unit? And then measuring the structural coverage. In aerospace, there's many projects which have to restart the complete unit testing once the assessor has seen or identified that you have done the testing only against the source code. And it's very easy to see if you have some experience in this area. You need to test against requirements, or at least against an architecture or a model, but not against the source code in itself. So the best way is to think about what is a unit, the size of a unit. Is it really the smallest entity, like the 2626T defines it, yeah? Or you're going a level higher and define a useful functional block of your software, a class maybe, a C++ class, which you test then in a still test software in the loop test, the software integration test. And for this integration test, typically, it's very simple, as these are then functional blocks. You have specifications. Yeah, you have, if you remember the V model I've shown you before, the software integration test on the second level, there's already the software requirements coming into the loop on the left side. And that's in the practice, the solution, yeah, or what is happening. And this means you have requirements, you can have requirements against integration tests, and then you can define requirement-based functional test results. And this is the way to avoid using the source code as a source, only source. And this is meaning not the other way around. Yeah, first define what are you expecting from a software functionality rather than a C function. Yeah, as functional results, defining it in the test, doing your tests, see whether this is passing or failing, and this is against your requirements, and then in parallel measuring your code coverage and see how far you're coming. And typically you're coming out to 80, 90, if you have small entity, 95%, in many cases, in 100% cases, yeah. Overall, the experiences, unit testing or software integration testing, you're getting up to 80, 85% of source code coverage, line coverage, or even MCDC. I would not even distinguish here very much. It's simple or can be achieved. It's not really a problem. Yeah, it's starting with above 80 or 85%. There, it's getting a bit more interesting. So what do I mean with this integration versus unit testing? Here, the right side is here unit testing. And even there, I have here a picture, split the units as these green bubbles, identifying a test to simple C functions, include C files, including more functions, 7 functions, yeah. But you could even do even function individually alone. But I split it to that. And the integration testing is collecting several C functions together. As the brown box here is then one software integration test. And you can already see in this diagram that you're then testing more data flows through a software. For example, control flows, this before that, yeah. And that's where are our failures and problems in our software. That's clearly known now since decades almost, or since years at least. So this powerful testing should be done. Here you're having such small entities that, yeah, you have individual units, but these units are not showing a lot of problems, yeah, or it's difficult to identify them in these individual units. So it's more powerful to do this kind of testing. And stopping then around what you're not calling. What you need here for this, to defining here these brown boxes for a software system, is experience, actually. Because if you make it too big, if you put the whole software as one software integration test, this is definitely not working either. Clear. But this is what you need. You need some experience in doing it. So typically for that are functional requirements available. Let us go to the next topic, the normal range test cases. The most valuable approach is to use, even for unit and module testing, one of the following informations about the software to be tested: functional requirements, architectural design, or at least some informal developer information about the software test. And if you're the tester itself, or the developer and the tester in one person, then start at one day in the morning as telling yourself, today I'm testing, today I question myself what I'm testing here. And this is a question, what is the input here? What shall this functionality provide? Actually, one sidestep, test-driven development is exactly the idea about it, yeah? Define the functionality and ask yourself, what shall my software do? And even that is a valuable input. Applying a combination of the following basic test methods is the secret of a valuable unit testing: equivalence classing, class testing, and combinatorial testing, like pairwise testing. So as you have typically, even on unit level, you have not only one input, you have several inputs. So equivalence classes are not alone helpful. You need to combine, and the combination of inputs is the overall test issues we all face and have. We cannot go into these details now in this webinar either, but just as a highlight, if you're not familiar with that, go familiar with these test methods in combination with error guessing. Like in the automotive industry, there is in the standard written error guessing. And error guessing is not a method. Error guessing is a mental attitude of a tester. Every tester, and if you're the developer and going as one day as a tester in your company, they're testing your own source code, take the head off saying, I'm error guessing today. I try to find a problem in my software, not I'm going to prove my software is working. Yeah, this is not the topic. You want to find problems. And that's the secret of doing good tests, yeah, to stress your system to find problems. And this will result in valuable unit and module tests. Another aspect, robustness testing. So this was now normal range testing, but already with a method behind, with equivalence class, boundary testing, error guessing, yeah, and error guessing is close to robustness testing, yeah, but it's not 100% robustness test. Error guessing is not really robustness testing. I want to choose to separate here even one step more, because you should first, with your error guessing attitude, finalize your requirement-based testing 100%, or your informal information, everything you have about your units and software modules you're going to test in normal range tests based on specification, formal, informal, yeah. You document the structural source code coverage, you get a high coverage level, 85+%. And then if you're finished with that, then you're going to say, okay, now I'm going to, if you want, validate my requirement and say, question my requirement and say, what else is missing? Yeah. What is my experience telling me? What are the customer is most likely to do with my software? Modules or software integration. Here, the modules are not enough. Yeah, it's much better to have a functionality. So software integration tests. Yeah. So with this functionality, what is the customer most likely to do? Or where is it used? And that's robustness. Yeah, because here you have no requirements anymore. You are outside of the specification, and then you're out of the specification, and then you're getting these robustness cases. And again, you need the error guessing, like written here. Yeah, here is even more important to use the error guessing aspects. It's actually the only way, and it's actually from a test method point of view, use experience-based testing. So if you go into the test books, experience-based testing is one chapter there. Here it is the most useful way in robustness testing. There you can use experience-based test methods. Or you have to, yeah, if you have no specification anymore. And this is the weaknesses of our specifications. What we're doing with robustness testing is covering the weaknesses of requirement-based engineering overall. Yeah, we know, all of us, we know with textual specifications, we are not able to fully specify a system. We are knowing that we have not even a method to fully specify a system, yeah, a software system. There's no way. Yeah, we can do a model, we can create a model, but whether this model is complete with the sense of its usage, with the validation aspects of it, we don't know. The model, a software model itself can be complete because this is mathematically proven. This is correct, but you cannot judge about the correctness and completeness of this model. And that's because of the requirement specifications. And we have no other methods than textual requirements, yeah, for having their completeness. And for that, to cover that, we have this experience-based testing. So that's what we're doing here. And this is what you should use in your integration testing as a strong method. So now, not finally, but coming to a more point which we will have a look in the tooling later on, actually. What is now about the structural source code coverage? Yeah, I have now strongly focused on normal range testing. First of all, having requirements, doing more integration than unit testing to be able to test against requirements, to support the requirement-based testing. If you're finished with that, question your requirements, question your information you have about your system, do robustness testing with error guessing mindset, and measuring the structural coverage always, yeah, in all these cases. This is what we shall do. And now we're coming to what is now the role of it, yeah. Yeah, if we are going to look in a project, we start with normal range testing, and we start with our first test case, then we are with our overall test coverage somewhere down here. Cost, time, we are very early, so we are here. And our structural coverage, 100% is there. So when you do the first test cases, we are very, very early. Typically, in software projects, due to the nature of the software, due to a lot of scenarios we cannot argue now here, you do not need many test cases. Typically, you need few test cases, yeah, and then you have already 50, 60%, let's say 50 plus, yeah, something between 50 and 60% of a project, or of a source code coverage, especially line coverage or statement coverage, this is very, very easy to achieve, but even MCDC is not so complicated. Yeah. A few, because we have not, in the source code overall, we have not so many decisions there and so on and so forth. So therefore, even an MCDC, you get with a few test cases, so much less than half of you need of them, yeah, you get a 50% of your source code covered. So this is a good sign and a bad sign, although, because here we are now in this topic, Pareto principle, 80-20, yeah. So we need 20% of our effort, kind of here, yeah, to achieve 80%. Is now not 100% correct in this slide here, but we are 80%. We are here, but 80% we are half of them somehow, yeah. And we have not finished. If you see here, the line is not finished, yeah, because here this coverage is going to an asymptote here, yeah. Mathematically, 100% is not achievable for almost any safety project, but you have to go as close as possible. So, and as I said, you're coming to a 90-95%. But this here, there, it costs the money, yeah, because you need a lot of test cases to make only a few progress, yeah. And this we're doing for highly safety critical projects, this effort, and we have good reasons for doing it. But if we have a non-safety project, we should be careful, yeah. We should stop here somewhere, yeah, saying, see, it's good enough, because time and money, the effort is maybe to be questioned whether this is worthwhile doing it in a non-safety project. So be aware of that we have here this way of completeness. Yeah. The point of why the structural coverage was introduced is actually the source code in itself is a mathematical representation. It can be defined 100% by mathematical equations. Otherwise, a machine could never execute a source code, yeah? As a compiled source code, a machine code. So this is all by humans, 100% can be defined in mathematical equations. This means taking these mathematical equations, we can define based on them 100% completeness, correctness, yeah. Taking here this diagram, this slide here, structural source code coverage, that's what I'm talking about here. The plus of it is the mathematical correctness or completeness, not correctness, the mathematical completeness, 100%. The structural source code coverage does not help to define whether the functionality is correct or not. This was never the idea. The idea was comparing these three methods, mainly which we have in testing a software system. We have tests, and we have requirements, architecture, or some information that we know what we're going to test. And the strengths of these things here is, so the dynamic testing and the requirements is functional description in the requirements, yeah, and the testing is proof of the functionality. The weakness of these two methods is completeness. As I said, requirements having 100% completeness, we never know. Testing the same. You have so many combinations of input values, there's no way, even mathematically, to test 100%. There is no industrial relevant system on the market where we would have any chance to test, however, 100%. It's by far too complex, any software system. So, and this was the idea to say, okay, the third method is the opposite. Yeah, there we have the strength and the completeness. So we want to do requirement-based testing. Yeah, these two together, and measuring with that the source code coverage, and then getting arguments whether if we have coverage or we miss coverage. Yeah, if we miss coverage, arguing or checking whether whether requirements are missing or maybe tests are missing. Yeah, that is the idea of structural testing. Not so much the functional completeness. This shall be done by the testing. Yeah, and the requirements is. Have I described completely my functionality, at least based off the implemented source code? Of course, source code which is not there cannot be tested, cannot be found either. This is also clear. So this is not a perfect solution, but considering with the industry or comparing it to the industry, we are far away in the industry, from my experience, taking even this thing here into account really in our projects, yeah, that we have a strong coverage, strong method, and this is the structural coverage with respect to completeness. Yeah, and that's what we should use the structural coverage for. And if you do assessments, or if you are an assessor, please focus on that. If people are there who are doing assessments in the automotive industry, there might be. We have to push this topic here. Yeah, that we are really using in software development, software testing, our methods. We have to develop proper software in a proper way. Yeah, this is the point on structural source code coverage. Now, reviews. Finally, before we come then to a tool presentation or answering your questions as far as we can. How do we successfully and efficiently perform test reviews now? The strengths of the weaknesses, strength and weakness of the elements of a software development process. A test specification, the test specification defines all relevant and specified aspects is a question or a weakness, if you want. Yeah, if you're talking about a test review, yeah, exactly, this is a test review now, not a source code review, not a requirements review. We're talking now about a test review. So then we can make a checklist, or we should do a checklist. We're saying, okay, is this test specification representing all relevant aspects? We are focusing with this checklist on the weaknesses of the software development process. The test specification defines the robustness aspects, all of them. Yeah, the weakness of the development process is completeness, as the requirements are not complete. So are our tests complete? Yes, no. The traceability from requirements, from requirements to test specification is correct and complete. This should be questions that should be proven in a review. And this is not, please, this is not the correctness of a DOORS or any Polarion or any requirement database traceability. This is per hand. You are looking into your test specification and you check whether this test specification completely implements your requirements or covers your tests, your requirements. And so far we have no machines, even not AI machines or algorithms, which are able to do that. We are strongly working on that, by the way, that we may be able to automate here some parts, but we are quite far away. HEICON has done a master thesis on that recently. So VR means the industry is working on this automatization here. But this is so far still per hand. Then the traceability goes a step further from the test specification to the test procedure. As we nowadays, hopefully 95% of our especially unit and integration tests are done by scripts, by tools, yeah, and not per hand. What is about our test script, equally test procedure? Can somebody who is reviewing it make a link between the specifications of what the test shall do to what the test is doing? Actually, yeah, the test procedure, is this correct and complete? Last point, or not the last point, that the test results are the right test results defined? Yeah, the expected test results, are they defined, and are the right one defined based on the requirements? So is these tests really proving the requirements? The test results are an important part. And it's not about whether the result itself is correct or wrong. The test result is what the software is delivering. Yeah, if it's wrong, then we found a failure. If the test result says passed, then our software is doing what it's supposed to do. But in our review, we should question whether we are asking about the right test results. That's the point. Last but not least, the test environment can be very wrong. Yeah, there are many cases where you say, okay, sorry guys, you're using here the wrong test environment. In unit testing, for example, do you compiling your source code with the same compiler switches like your original source code? Has anybody reviewed this when you're doing your unit testing? Yeah, because this is for using our compiler. And can we use the testing for proving that our compiler is correct? And compiler switches are important in this area, as you all know. So please set up your compilers your compiler switches in the same way. If you use optimization in the original source code, then use it in the testing as well. And this, you're proving this here by review. And this is now an example for a checklist. And here you have passed fails in the response, and you have, if you have a failed, then you have further down in your tooling the answer, the feedback on this checklist. And this makes then a relevant, proper review. So I hope in the short time we have that you get some idea on a review, or you may know already, or you have it, you do it already. This would be the nicest for me. The take-home message now, finally, before I hand over to Roland and answering your questions. Finally, so perform white box testing equal unit and integration testing just with the goal to prove the structural code coverage is meaningless. First step. Beneficial white box testing is driven by proving the functionality, not the structural source. The structural source code coverage is just the completeness check. Yeah. As the third point here, the structural coverage provides hints towards the completeness of testing and specification. That's where we have to shoot for. Review of the test is a very effective mean to keep a high quality of the tests. Didn't say it so far, but my experience is clearly, if I come to customers where I do no test reviews, the likelihood that the quality of the tests are low is very, very high then, yeah. As testers are also not the better people. Yeah? As testers are doing the same failures. Every humans are doing failures. We all humans, we're all doing failures. So as I said, for I principle, we should have also a look into the tests. A very powerful mean, if you have not the money and the time to review each and every test, and you have not such a safety critical test maybe, go to your quality department and ask them to review 10% of your tests. This is already very powerful. 10 to 20% of the tests. If the guy who is doing the reviews have some experience, he chooses the right 10 or 20% of your tests, and he finds then there's a high likelihood important problems or not, and this is good enough. That's what you want to have. This is a quality assurance measure everywhere. Yeah. Also in production, you're not checking each and every production result. You're taking samples, 10% of your produced products, and you're checking them. And that's we can use here for software testing results. So please do that, go into that. And my last slide now. Thank you very much. You see, it was a powerful, a lot of information in a short time. You have an overview, or you can get an overview now, or you have hopefully an overview, but there's a lot of details there. We can do a 2-day seminar or even more about it. So now, Roland, I hand over to you, and in parallel, I'm checking the chat and the questions, and we are answering it after your presentation in the final step.
Yeah, there are already 2 questions in there, so take your time and read it carefully. So thank you, Martin.
Thank you very much.
Yeah, and I know that he can talk 2 days about these topics because actually he's doing that when he's doing other seminars for us. You can ask you can book Martin to come into your company, or you join one of the seminars we have. So the chat is still open. Martin is reading it, and I try to share my screen now, and I want to show you.
Going to share now.
Yeah, just a second. Now you should see the starting slide, Martin, correct?
At the moment, I have
nothing.
Give me a second. Yes, I see.
Okay. Okay, then let's start. So, yeah, myself, I'm working as a technical consultant. I'm Roland. And simply said, I try to help the customers get familiar with our tool. And Martin already mentioned the different aspects on testing. So we saw a lot of dimensions, and with our code coverage analyzer, we look at one of these dimensions to measure the structural coverage. We talked about white box testing, and sometimes the white box is not so clear, not so white as you might want to like it. So let's say we take our tool is like putting a flashlight into the white box to see more clear what you have tested, not if your tests are good and so on. But this is what we do. We give you more transparency about the coverage of your tests. That's what we do. And I give you a very, very short introductions because I see in the participants today, we have a mixture of customers that already know our tool and some that are might interested in. So let's start with an overview of some bullet points that should emphasize when our code coverage analyzer might be very interesting to you, not only interesting. When you look for code coverage analyzers, there are a lot of tools in the market. We are specialized to even measure the coverage when you run your software on the embedded target, not on the host machine only or in a simulation mode, but when you run the software where it runs at the end. So this is some special things. We can use our tool with almost every compiler, cross-compiler. These are two aspects in this message. The one is commercial. And the commercial one is that you only have to buy one license for the platform where you're using it. But it doesn't matter if you use today a GCC, tomorrow a CL or Clang, or whatever target you are using. This is not bound to our license. It's not. It's also not bound to lines of code, to the size of your project. You buy a license on a platform, and whatever project you can measure code coverage with our tool, you can do so. The second is a technical one. With every compiler means that we don't have a positive or negative list of compilers, but in fact there are some lists that you find on our homepage, but that's not the key point. The interesting thing is that we can train in compiler behavior to our tool. So even a compiler that is released tomorrow, and we do not know today, if he has the behavior, the generic behavior of a compiler to pre-process code, to compile it, to link, then we can teach in somehow the compiler to our tool. So it's future safe to go with our tooling. We are compliant to safety critical standards. That has also two dimensions, this message. The one is that we cover all the coverage levels that are asked. So when we talk about code coverage, it's not so simple as it looks like in the first instance. There are different levels. Martin mentioned like line coverage or statement coverage, but there are higher levels, and the highest levels we know from the standards is MCDC, modified condition decision coverage, and not all of the tools can measure MCDC coverage. So if you are in the automotive industry and you have your ASLD project, then yeah, you have only limited tools available in the market that can help you measuring the code coverage that is asked by the standard. And the other aspect, the second message in this compliant to safety critical standards, is that we have our latest release. We have a TÜV certification. So the TÜV certificate, I'll show you later, that enables you to safely use the tool, or that you are allowed to use it. So you can assume that this tool does what it should in your safety critical development. And for older versions of CTC, we have a qualification kit available where you can do the qualification more simpler in your environment. As we run on embedded targets, we have to be careful with the resources we bring into the application. So to measure code coverage, we have to have some code injections, what we call instrumentation. And with different measures in our tool, we can keep this instrumentation overhead minimalistic. The languages we can cover are mainly C, C++. This is these two languages. The first two languages are the ones the tool is designed for. Java and C# are supported by add-ons, but this is not our strength market. So if you have C, C++ projects, which are still the two major languages in embedded targets market, over 90% of the projects are in C, C++, then you, yeah, you will be happy using Testwell C, C++, quite sure. Now coming to the tool, how does the tool work? Testwell C, C++ is not a single application, but it's a collection of a lot of tools, and they are mainly command line based. So at the end, a tool is running on the command line, so you can easily integrate it in almost every kind of tool chain, CIs or things in the cloud. That's not an issue. But it's important to understand these basic 3 generic steps to measure code coverage with our tool. And we talk about these three phases: instrumenting, testing, reporting. And you see the testing, it's a white box here. It's not really white box testing. It shall say to you, so you need our tools for instrumenting the application, and we have some tools to do the report, but the testing can be done however you want it. In the right side of the V model, you've seen from Martin, you started with unit testing on the lowest level up to integration testing or on the hardware. So we don't care. As long as the code is instrumented, then testing will work together with CTC and will give you some coverage. How do we do this? We see here a simple workflow, as you already all have it, even without measuring code coverage. So we have source code, we compile the source code, we get an executable, and we do our tests. And this is the one dimension that Martin mentioned. So the quality of your test is something, or you would like to have that all tests pass and none of the tests will fail, to see if the functionality of your software is correct. But this has nothing to do with coverage. So even if every test is failing, you would still have some coverage. We measure coverage and not the quality of tests and not the functionality of your software at all. How do we measure now the coverage? As already said, we have 3 phases. The first one is the instrumenting, what we call instrumenting, injecting code by a tool here named CTC. And this tool would replace in a copy of your source code a line like if is ALO 10 with an enriched line of code with the same functionality. We still have the same decision within this line of code, but we have additionally introduced a ternary operator to implement counters. Whenever this decision was true, we increment a true counter. When it was false, we increment a false counter. And this is one sample, a generic sample, how it works. We create then some artifacts. I'll speed a little bit up. We do the testing, or you do the testing. You do the testing the same way you ever do it. And then we get a second artifact. As we have instrumented the code, it will automatically count. And in the third step, we do the reporting. And this is one sample report, how it looks like. You can define the levels you want to see, if these are directories, files, functions. In the newest version of Testwell CTC++ that we released last December, we have a really new design, brand new design, and a brand new tool to create the reports. And we will do a lot of enrich with this tool with more features in the near future, to do justifications, for example. So these are cool things that will come. And this is one sample how it looks like. So we have here aggregation views, and we have at the end the source code to you, where you easily can see with background colors or with counters, with true and false counters, which kind of your code was hit by your tests. As I already mentioned, with the latest version of Testwell CTC++, the version 10, we have a TÜV certificate, and for here 4 named standards, automotive, railway, medical, and functional safety. We have, you can use this tool right away without further tool qualification. There is one gap in this list. This is the aerospace industry. So if you are in the aerospace industry, you still have to qualify the tool. We can help you to do so when we deliver tests. Okay, so coming to an end, we have a lot of integrations to IDEs so that you can start measuring code coverage from your normal workflow. We can integrate it on build machines or in cloud things and in unit test frameworks. We can run on almost every target, and it can be adopted to all compilers. And it's, as we have this tool 30 years in the market now, there are a lot of compilers that are working with the tool already from scratch. So yeah, if you're interested, feel free to contact Paulina, who's in the line, our sales team, and you can get a free tool evaluation license. Free, it's almost free. You have to bring in some time, but it's without any cost. And we give you full support during this evaluation period. So that's in short my presentation. Thank you for participating, and I hand over to Paulina. Paulina, it's your turn.
Yeah, so thank you everybody for your time, for participating in the webinar, and thank you Martin and Roland for the presentations. And if you will have any questions, feel free to contact us anytime. So have a nice day, everybody.
Are there open questions in the chat?
Yeah, there are open.
Okay,
yeah.
let's go.
Roland,
let's take some 2 minutes.
Yeah, exactly.
Okay, Martin, did you?
MATLAB Simulink, MATLAB IDE and XC8 compiler. Is the tool working? CTC working in this environment?
We know, yeah. So it's almost, so it works with every compiler and the MATLAB. If you have IDEs, we don't have an integration to this IDE, but we have a lot of tool vendors that integrate our tool, like PyTech in TPT, it's integrated, or Razorcat in Tessie. They even use our code coverage analyzer. And I know MATLAB projects that are interact with TPT and so on. So I would say yes, it will work with it, but you have to evaluate how it works, and we support you on this.
Another question, Roland, can you please explain a bit the content of the MON.sym and the MON.dat?
Okay. Okay. In this short time, no, but okay. MON.sym is a human readable file, and the content is what we have instrumented, what we have injected in your code. So to see what we did during instrumentation. And MON.dat is a machine readable file, a binary file created. Both files have a special target. So MON.sym is not to integrate all this information into the application. We want to keep the application as small as possible. So what not has to be in the application during instrumentation is in the MON.sym, so that we know later what it is. And the MON.dat is minimized to make this testing, the output of the counters, smooth as possible. So there are only the values in there. So, and MON.sym and MON.dat in this combination, so what was the counter and what is the counter value? This is combined by the tool in whatever kind of report, in this case, a HTML report. So that's in very short what the MON.sym and the MON.dat is.
So and now me, very short answer. I have already written it in the chat, but for all others of you, there's a question about which department shall be involved about the test reviews. And clearly it's the test department itself. Yeah, there is not a separate department. Or in smaller companies, if it's possible to have a separate department, it's the quality department. In the German machinery industry, I'm arguing a lot to try to involve your quality department to make them fit for be able to review tests. This would be helpful a lot. But overall, it is the test department in itself. Anyway, you have to show and to prove that not one tester does the review of its own test, the same as with the software development. You have to take care that this is independent people, but there is not another department, or this is too costly or too intensive. Then there's a tooling issue.
Yeah, there's one. Oh, you still have one? I also have one. Okay, proceed, Martin.
the 0% coverage thingy on C unit. This kind of problem that the tool is not, I understand the question, the tool is not showing you that there is a problem, that it's not measuring properly the coverage. Yes, this is happening in several cases. I can tell you several cases of tools which are not showing the things properly, yeah, or good enough, because the tool vendors want to show you nice things. Yeah, they want to have a nice tool. Yeah, a test without a test result is green, for example. Such things are also existing, and that's bad. But this is because of the tool vendors, and it's the part of the test review. You have to review, or you have to set up your test environment, and you have to review it properly, and it's your responsibility to make it proper. And that's the argument for this last question in my review sheet. Finally, the functional test coverage. Yes, this is engineering judgment in very short. I have written some text for that. Either go into the seminars about pairwise testing, equivalence class testing, boundary testing, there is an engineering judgment whether it's complete or not. There is not 100% yes or no answer for functional testing. And there's also not really a lot what you can measure. What people are doing is using, even in hardware-software integration testing, measuring the code coverage, and making, due to the experience, some conclusions about the quality. But this is a bit of another topic. So as we are anyway 5 minutes over time.
Two more questions. Two maybe important. Please read the last one, and I have one from the other one. Interesting one. Is this instrumented code then used on the target later in final product or not? Or is it removed? It's not in the final product. The tool what we have is a verification tool. So that's an interesting and important question. It's not intended to keep these instrumentation overhead in the final product. And usually if you have built system, you implement two different build runs so that you build it for delivery, for production, and you deliver and you build one pipeline for measuring code coverage. So it's not intended to be there. It can be, but I wouldn't recommend it, and I don't think that this is a practical way.
It's not a good idea, definitely not.
Yes. Okay.
So then the last question is about the main point of a test case review. So only one, I would say then traceability actually. Show me that even your test procedure implements the test specification, and show me that the test specification implements the requirement properly. So overall, I would call it traceability, but I have 5-6 questions there for good reasons. But this is for me the main point if you want. Okay, you see 6 minutes overtime now. But this is testing sometimes. It takes some more time. This is just like it is. So Paulina, finally, the last words on this webinar for you now.
So the second attempt. So thanks a lot. It seems there are no more questions, right? So all questions are answered, and thanks you all. And if some questions appear, or you will remember later that you would like to know something, or if you would like to evaluate our code coverage analyzer, Testwell C++, then just feel free to contact us anytime. And thanks everybody again, and have a nice day and rest of the week.
Bye-bye.
Bye.